Okay, so hi everyone. Today we will be doing the example session on light. I will be doing questions with you in multiple choice format. So let's start. So this is our first question. When light strikes a smooth surface, it bounces back. This phenomenon is called what? Reflection. Right? The ray of light that falls on a surface is called the incident ray. The ray of light that bounces off a surface is called reflected ray. The point where the incident ray strikes the surface is known as the point of incidence. If you remember, like this: incident ray, reflected ray, point of incidence. The line perpendicular to the surface at the point of incidence is called the normal. This is the normal. The angle between the incident ray and the normal is called the angle of incidence. Alright, see this is the normal. Alright, this goes like this goes like this. This is angle of incidence and this is angle of reflection. According to the laws of reflection, the angle of incidence is equal to the angle of reflection. Alright, now what is the primary use of a plane mirror? If you remember a plane mirror, there was a girl standing in front of this plane mirror, and alright, so there is a person in this plane mirror. What were the properties of plane mirror? It will show the same size as the person, same sized image. It will be erect, that means straight. What is the primary use? Reflecting light to form an image. The image formed by a plane mirror is virtual and erect. Like I said, add virtual. When parallel light rays pass through a concave mirror, if you remember concave mirror, it is bulging inside, not outside, it is bulging inside like a C. A convex mirror would be like this. Alright, this would be this surface, this would be the surface, light will come over here, in this light will come over here. So in a concave mirror, the light rays will converge. Alright, but in a convex mirror, they will diverge. In a concave lens, they will diverge. In a convex lens, they will converge. Alright. Now, when parallel light rays pass through a convex mirror, they diverge. We can write it here: convex, concave. Okay. Mirror, lens. Convex mirror, it diverge. Concave mirror, they converge. Convex lens, they converge. Concave lens, they diverge. Alright. The ability of a lens to bring parallel rays of light to a focus is called its power. Alright, so supposedly there is a lens, okay, goes like this, and there is also a line in the middle. How nicely it can focus that image, alright, bend it, that is the power, of the lens. Alright. A lens with a thicker middle and thinner edges is called a convex lens. Alright, see, this is a convex lens. I will draw it better. This is a convex lens. Okay, thicker in the middle, thinner at the edges. The lens that corrects the defect of nearsightedness is convex lens. Nearsightedness, myopia. The phenomenon of bending of light as it passes from one medium to another is called refraction. Refraction. Alright, bending. What was reflection? It was bouncing. Refraction is bending. Alright, from one medium to another. Suppose this is air, this is water. Light traveling from here in this direction will bend in this direction. The change in direction of light when it passes through a prism is known as dispersion. Alright, not refraction. It is refraction, but when it is done through a prism, alright, a prism like this, and it diverges into 7 colors, alright, that is dispersion. Always remember. The eye defect in which distant objects appear blurred is called myopia. You are able to see near, not far. Alright, myopic. You can see the short distance things but not long. Okay, that is myopia, in which distant objects, something placed far, suppose there is a tree far away, it will appear blurred. Alright, this is myopia. Sometimes you are not able to see the board. Alright, that is myopia. The eye defect in which close objects appear blurred is called hypermetropia. Alright, hypermetropia. The eye defect that causes irregular focusing of light on the retina is called astigmatism. If you go back to the notes, I have told you about astigmatism, that is the eye defect that causes irregular focusing of light on the retina. Alright. The eye defect that occurs due to the loss of flexibility of the eye lens with age is called presbyopia. Remember, the key word is with age, old age. Lens becomes less powerful. It is not able to adjust the lens of the eye. Which optical instrument is used to see distant objects more clearly? Telescope. How do you see stars, planets? This is used in astronomy. Which optical instrument is used to view objects from a hidden or inaccessible location, like in a submarine? Alright, what is this for? To view while being inside. Okay, what is this? It is a periscope. Periscope. Which optical instrument creates a beautiful symmetrical pattern by reflecting light multiple times? This is a kaleidoscope. Alright, a kaleidoscope. When light passes from a denser medium to a rarer medium and the angle of incidence is greater than the critical angle, that is called what? If you remember, in a diamond, alright, light rays enter this way, this is a critical angle, but the angle of incidence is more than the critical angle. It will go a lot of refraction, a lot of bending, while ultimately it comes out. Okay, so this is total internal reflection. If you go back to the notes and you see, this is total internal reflection. That is why it appears very shiny, sparkling. It's going from a denser medium to a rarer medium while the light is coming out. Diamond is dense, air is rare. Okay, so it comes out like this. The critical angle is the angle of incidence when the angle of refraction is how much? Alright, so do remember this. Critical angle is the angle of incidence. That means critical angle is equal to angle of incidence when the angle of refraction is 90 degrees. Angle of when the bending is at 90 degrees. Okay, so it's going this way and it's going this way. This is a 90 degree. Okay, that is when the angle of incidence is equal to the critical angle. All right. The phenomenon responsible for blue color of the sky is what? Scattering, refraction. Blue color of sky, redness of sunset. This is all due to refraction. Alright, atmospheric refraction. Okay, how? Blue light is least scattered during the day. Alright, scattered means it is not diminished. Alright, so blue color is least diminished during the day amongst the band of Vibgyor. Alright, so blue will be less scattered during the day, that's why sky appears blue. During the evening, when most of the light is scattered, alright, only the red color, it has a very small wavelength. Alright, small wavelength. It is not easy to scatter. That's why we can see red color in a fog, or when no color is visible, you will be able to see red. Alright, and that is why there is a redness of sunset, because the sun is going down. Alright, which of the following is not a property of a convex lens? Converging of light rays, real and inverted images, thicker at the edges, used to correct nearsightedness. Used to correct nearsightedness is not a property of convex lens. We do not use convex lens for nearsightedness. Alright, so option D. Converging of light rays, yes, a convex lens does that. Real and inverted images, inverted means upside down. If object is like this, image will be upside down. Okay, if this is a tree, image will come like this. Okay, thicker at the edges, it is thicker at the edges. The power of a lens is measured in diopters. This is the unit of power. The transparent part of the eye that focuses light onto the retina is called cornea. Alright, the transparent part of the eye, this is the eye. Okay, there is cornea over this. Okay, it helps us focus light onto the retina on the back of the eye, that is cornea. Okay, so that will be all for today, and I'll see you next time.